Alright, humans, so functions have a number of purposes, one of which is to encapsulate a set of operations. So let me just write down a set of operations. Let's say pi, radius. So times pi, radius, and radius, alright? So what does this set of operations mean? What does it calculate? Well, you remember from geometry class or something, or some math class. This is the formula for calculating the area of a circle, alright? So let me hit Control R and run this code. It says this variable is not defined. Well, of course, because let's just make the variable radius. It's not finding it, because we have to make it. Hit Control R, and we get the area of a circle that is of radius 5, which is 78.53981, and then a lot of decimal places afterwards. So what this hash I means is that these decimal places go on forever. They divide forever. And since computers are really finite in memory, right, the kilobytes, megabytes, gigabytes, etc., we're not going to calculate all the infinite decimal places. We're going to give you a number that's close, but still inexact, just like pi. Pi has decimal places extending forever because it divides forever. And this hash I again just means, hey, this is a close approximation. It's inexact, but it's still close. All right? That's again due to the limits of computers being finite in memory. So notice how I had to explain what times pi radius means. That's not good. I can do better than that by creating a function and giving that the name, all right, which is the area of a circle. So let me define a function called area of circle. It takes in a parameter, a variable called r, and inside the body of this function, it will use this r to calculate the area of a circle. So if I use this function by opening parenthesis, opening and closing parenthesis, and then the name of the function, area of circle, and giving it, let's say the number 10, right, hit Control Run, we get the area of a circle for a given radius 10, all right? So what's happening here? Well, this 10 will get plugged into this r. So let me just copy this. So this 10 is go over here, and r is now going to be 10. And inside the body of this function, we're going to replace all instances of r with 10. And then it will just perform this calculation inside the body, times pi radius, and that's why we get 314.153159, etc., right? So if I just run this manually, you get the same thing. So that's what I meant by functions encapsulating a set of operations. And this is what I mean by giving it a name. We gave it a name, area of a circle, because that's what this does. We can give it a different name. Let me just rename this to something silly like poo, right? Hit Control Run. And we get area of a circle. This function is not defined. Well, I just renamed this function to poo, so of course this has to match because I can't find this function anymore. Hit Control Run. It does the same thing. It calculates the area of a circle, just using a silly name. So I'm going to undo this because it's better if you name your functions well as to what they do rather than something silly. This is an example that these choices of names are completely arbitrary. This R can even be silly. It can be ASDF. And then ASDF here. As long as it matches in the body of the function, it doesn't really matter. But I'm just going to name it R because it's clear what it is. It's the radius, all right? So, yeah. So that is creating a function with the name area of circle, having it take a parameter called r, and substituting and doing that calculation for us is better than typing out the formula manually. And you can guess sort of why. Because if I just read line 11, if I just focus my eyes on line 11, I immediately tell at a glance what it does. Area of a circle 10, well, I can guess that this 10 is the radius, and this whole thing is going to evaluate to some number, and that number is going to mean the area of a circle. Whereas if you just look at line 5, solely at line 5, right, times pi radius. Well, I forgot, all my geometry or something, and now I got to look up what's times pi radius, Google. Oh, it's just the area of a circle, right? You can easily tell what things mean at a glance if you wrap things around functions and give it a name, which makes things more readable, right? Not only more readable, but it factors out duplication. So it factors out duplication by creating a variable for us in a temporary environment and then, doing the substitution for us. So on this call, this area of a circle given radius of 10 is 314.159. But let's say on another run area of a circle, I want the area of a circle given the number 15, right? Then on this run, this 15 will be plugged into this r, and now r will be 15, and this will give us the radius of circle for radius 15, the area of a circle for radius 15, so 716.85, all right? So the alternative is, if we never used functions, we're gonna have to keep copy and pasting these two lines, right? So instead of 5, I want the radius of 7, right? And hit Control R, we get radius. The name was previously defined. The name was defined previously and cannot be redefined. So radius and radius. There are two variables called radius. One of them has to be unique. So this has to be named radius 2. And then we have to do it here too, here too. All right? It's just very, very tedious. And if we hit Control R, we get the radius of 7, which is 153. We want another one. We have to copy and paste these two lines. And then, do a radius 3. I want to calculate the radius of a circle given, let's say, 8. Well, this would have to be here. It's really, really tedious. Whereas compared to a function, right, we just do this. Area of circle 7, area circle 8, and that'll do it for us. It will create a variable called r. It'll be 7 here on this run, and then 8 on this run, right? So that's what I mean by reducing duplication. So here's another example from our previous exercises where we made some stop signs. So this is a stop sign of size 30 over here. Say you wanted a stop sign of size 60. Well, you would have to copy and paste these 4 lines, paste them down here. This would be 60. This would be stop 2 hex size, and you have to rename all your variables here. Hit run, and then you would get your stop sign of size 60. If you wanted another one, that would be another copy and paste these 4 lines, copy and paste down here. This is going to be size 90, right? And then you would have to rename this variable 3. Just a lot of work here, right? To get another stop sign. If I were to ask you to create 100 of these, well, that's at minimum, 4 lines times 100 stop signs. So that's 400 lines of code that you have to write, of copy and pasting. With functions, we can, again, factor this out, right? Encapsulate the set of operations, give it a meaningful name, and reduce the duplication by quite a lot. So we're going to give it a name called make stop sign and size, and it's just going to encapsulate these set of operations for us. All right, but instead of referencing a variable that's way out here, it's going to take it in from the parameter, right? So this should be size. Okay, there we go. Size. Hit Control Run. We defined the function. We haven't used it yet, so let's just use it by saying make stop sign of 30, make stop sign of 60, and make stop sign of 90. All right. So we created 3 stop signs of varying sizes in one line of code, right here: 25, 30, 60, and 90, just by creating 4 lines of this function definition. So you see 6 stop signs. These 3, the last 3 correspond with these function calls, and then the first 3 correspond with this, huge copy and pasting block. So you can delete these, and again, if we hit Control Run, same result as we wanted before, right? Stop signs of varying sizes, but in a much shorter and concise way. And if I were to ask you to, write 100 stop signs, well, it's just going to be 100 lines of code rather than 400. That's a factor of 4 in terms of reduction, right? 104 actually, because you have to write this function definition. But 400 from 100. Again, that's a lot of duplication saved from writing a function. So lastly, let's go over the precise vocabulary revolving around functions. All right, it's going to be quick. So to create a function, it's open parenthesis, the keyword define, space, another parenthesis, and right after that is the name of a function. So in this case, this example, it's called make stop sign. What about for this case, right? What's the answer? Well, it's area of a circle, right? That's the name of this function. The name for this one is make stop sign. So after that, a set of arguments, right? It names a set of arguments. In this case, it's called size. In this other case, it's just called r. All right? It can be an arbitrary amount of them. So you can have two arguments. Let's say like hi. Of course, I would have to use this, but I'm not going to use them. So this is better if it's just one argument for now. So I'm going to indicate this by ... indicating that it can take a number of arguments. All right? Followed by a closing parenthesis for this block. So you can see here, we're matching this. Hopefully you see the distinction, similarities, I mean. All right? And the body of the function will use those arguments. All right? And then followed by a closing parenthesis to close the entire block of the function. All right? So I just wanted to mention that we've been using functions this entire time, right? Rectangle is a function that takes 4 arguments, 2 numbers. One is the width, so I'm going to say that's 200. A height, that's 100. And then 2 strings, that's the mode. And then the color, say green. Do Control R. And here, this function produces a green rectangle. All right, so we've been using functions all along. Today, you learned how to create functions, and you know that they encapsulate a set of operations. In this case, area of a circle encapsulates the formula to create, to calculate the area of a circle. And this one encapsulates the operations needed to make a stop sign. It gave it a meaningful name, so we can clearly see in one line that this just calculates the area of a circle. And in this one, it just makes a stop sign. See how it reads really easily, right? Whereas if we just overlay these 3 lines, it's kind of like to do some decoding, also with like times by radius, right? Lastly, reduce duplication. So remember how we had all the copy and pasting to create stop signs of varying sizes? Well, now we can just do this in one concise line. Same with this. Calculating radiuses of 7, 8. It's 2 lines here, but if we create a function, it's 1 line, and no need to type out this formula. Also, sometimes you can get tired typing out this formula all the time, right? You would do like times pi radius, and you're like really tired. You forget the other one, and your formula isn't all wrong. We can write a function again to factor that out and do it for us. So that's functions. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.